Assalamualaikum warahmatullahi wabarakatuh. My name is Haida Natasha Binti Shamsuddin, and I will present my final year project, which is the evaluation on antibacterial and anti-inflammatory activities of Azadirachta indica. I was supervised by Dr. Mama Akmal bin Hashim. Let's begin with the introduction. Azadirachta indica or A indica is an evergreen tree and was found in many tropical countries including Malaysia. It was believed to have antibacterial characteristics as in India, A indica was used to cure the chickenpox and as anti-inflammatory it was used to suppress the swollen gland by Oman people. It was believed that A indica contained compounds that exhibit the bioactivity as antibacterial and anti-inflammatory. In this study, there are four objectives to be achieved, which is to evaluate the antibacterial activities of A. indica leaf against E. coli and B. licaniformis, to evaluate the anti-inflammatory activities of A. indica leaf using heat-induced protein denaturation method, to compare the effect of different percentage of ethanol extract used against E. coli in B. licaniformis, and also the effect toward the heat-induced protein denaturation. And then the last one is to identify the phytochemical present in the leaf of A. indica. Moving to the research question, there are a few research questions that have been arised, which is how to evaluate the antibacterial activities of A. indica leaf against E. coli and B. licaniformis. Second, how the anti-inflammatory of A. indica leaf will be determined. Third, does different percent of ethanol used as the solvent will affect the bioactivity of A. indica as antibacterial and anti-inflammatory? And the last one is what is the phytochemical presence in the leaf of A. indica? Moving to the problem statement in this study, there are some issues that we identified. The problem is the prevalence of antibiotic resistance of pathogens has prompted considerable efforts to identify new antibacterial. Next, the prescribed medications of anti-inflammatory properties have side effects such as neurodegenerative, and natural products such as A. indica are legitimate and it should be used as the alternative source of anti-inflammatory or antibacterial instead of synthetic drug. There are a few significance of this study, which is to reaffirm the potential of antibacterial activities of A. indica leaf as a natural product. Next, to further elucidate the anti-inflammatory activities of A. indica as a natural alternative source in healing the inflammatory. Other than that, it is to identify the best attraction between different percents of solvent use that will exhibit the highest bioactivities as antibacterial and anti-inflammatory. This study also potentially to improve the economy of rural people by providing opportunities for them as a supplier of materials in natural products development. The study of antibacterial and anti-inflammatory of A. indica have been carried out by several researchers, among them Mishra et al. 2019. It is found out that A. indica ethanol extract effective against E. coli and S. aureus. It also confirmed the presence of the flavonoid, glycosides, tannins, and also the saponins. Other researchers, which is Chauhan 2015, revealed the effectiveness of aqueous, methanol, and ethanol extract of A. indica leaf against some bacteria, and it was recorded that E. coli has the highest inhibition zone in all extraction used. For anti-inflammatory study, a study from Kumarvandana et al. 2015 revealed that A. indica leaf extract have anti-inflammatory effects in albino rats. The extract with 500 mg shows the highest inhibition of edema with 63.01%. Next, a study from Kulani A. et al. 2021 investigate for A. indica anti-inflammatory and analgesic activities. The result shows that at 4 hours, neem seed oil inhibit edema the most at 53.14%. The methodology for antibacterial activities. First, preparation of A. indica leaf extract. Next, preparation of MHA and Newton broth, and after that, prepare the bacterial culture. And then, perform the antibacterial test by using the disk diffusion method, and lastly, measure and record the zone of inhibition. The methodology for anti-inflammatory activities. First, preparation of test solution extract with different concentration. Next, preparation of test solution of standard with different concentration. After that, all the test tube was incubated at 30 degrees for 15 minutes. And then it was heated at 70 degrees in water bath for 5 minutes and cooled the test tube for 15 minutes after that. And it was measured with spectrophotometer at 660 nanometer, and the formula was used as shown. The antibacterial activity of A. indica. Figure shown is the zone of inhibition of A. indica leaf extract against E. coli. On the left is the result for 95% ethanol extract, and on the right figure is the result for 50% ethanol extracts of A. indica against E. coli, while this is the result for antibacterial activities against B. licheniformis. All of the zone of inhibition was recorded in this table. A. indica was tested for the potential to inhibit the growth of E. coli and B. licheniformis. The diameter of zone of inhibition was measured to determine the antibacterial activity at three different concentrations, which is at 50 mg per ml, 25 mg per ml, and 12.5 mg per ml. This evaluation was compared to the negative control, which is DC water, and the positive control, which is the ampicillin. The result shows there are no zone of inhibition against E. coli for 95% ethanol extract of A. indica leaf at all concentration except for the concentration of 50 mg per ml. It is with 10 mm and the value is not susceptible against E. coli. Meanwhile, for 50% ethanol extract of A. indica leaf, there are no zone of inhibition at all concentrations against E. coli. For B. licheniformis, it also shows the same result for 95% ethanol extract of A. indica when there is no zone of inhibition at all concentrations. However, at concentration of 50 mg per ml and 25 mg per ml of 50% ethanol extract, there is a zone of inhibition of 9 mm and 8 mm respectively, but the value is not susceptible against B. licheniformis. This study was contradictory to the previous study of Bin Imran 2015 and Mishra et al. 2019 that revealed the ethanol extracts are effective against E. coli and other bacteria. The negative antibacterial activity results for A. indica in this study did not indicate the absence of bioactive constituents or that the plant is inactive. However, there may be some error while running the test. The extracts may contain insufficient amounts of the extracts to exhibit activity as only 5 microliters of extracts were pipetted under this filter paper. Moreover, the amount of 0.7 ml of E. coli and B. licheniformis used was too much and make it a little bit stagnant on the agar layer, so that the filter paper used was a little bit raised and it did not fully contact the layer of the agar. Thus, the phytochemical and compound being extracted cannot fully contact and diffuse on the agar layer to show the effectiveness. The anti-inflammatory properties of A. indica were evaluated using the heat-induced egg albumin denaturation method. It was carried out according to the methods described by Sharma et al. 2021. The egg was prepared for use as an albumin source. The concentration used were at different concentrations, which is at 1 mg per ml, 0.5 mg per ml, and 0.25 mg per ml, and it was compared to the standard, which is the diclofenac sodium. From the table, it shows different percentage of denaturation. The protein denaturation of 95% ethanol extract of A. indica at concentration of 1 mg per ml shows the highest denaturation at 55.35%. Meanwhile, for 50% ethanol extract of A. indica leaf shows the highest denaturation at 30.35% at concentration also at 1 mg per ml. The comparison of the bioactivity are shown in this graph. The highest inhibition is by the diclofenac sodium and followed by 95% ethanol extract of A. indica and the least denaturation by 50% ethanol extract of A. indica. The qualitative phytochemical of Azadirachta indica leaf. From the qualitative phytochemical test, it was identified the presence of flavonoid when there is a silvering form at the bottom of the test tube. The alkaloid was confirmed when there is white precipitate form, and the saponin was detected when a layer of 2 cm bubbles was formed. To conclude, for antibacterial activities, both of the 95% and 50% ethanol extract of A. indica do not show antibacterial activities and do not susceptible against E. coli and B. licheniformis. For anti-inflammatory, the 95% ethanol extract of A. indica shows anti-inflammatory better than 50% ethanol extract of A. indica. The phytochemicals present in Azadirachta indica leaf was the saponin, alkaloid, and flavonoid. Thus, the objective for this study was achieved. There are a few recommendations for A. indica to be further investigated. It is recommended for the researchers to take the opportunity to continue investigating the potential of A. indica as a natural alternative anti-inflammatory medication without the side effects. It might replace the synthetic drugs such as diclofenac that can cause the kidney damage. Other than that, the endemic situation of COVID-19 and HIV/MD phenomenon has urged the modern researchers to further study the potential of natural products such as A. indica as natural disinfectant and antiviral products such as hand sanitizer and antiviral cream that can be commercialized.
That's all for my presentation for today, and here are some references for you to refer. I also would like to thank you for your time and your attention. Have a nice day.